My slides are here. Thank you. So it's after lunch. We're going to do the traditional post-lunch subitization. Are you ready? You know what to do, right? No. Does anyone know what to do? Okay. Subitization is a technique used in psychological experiments, and the idea is that you look at a quantity of things for ideally not enough time to count them, and you try to recognize how many things are there. So you're not going to do this out loud. You're going to keep it to yourself, but you're just going to see how good you are at recognizing how many objects you see at a time. By the way, I'm Chad. I'm from Microsoft. He asked if he should say anything else about me, and I think that's probably good enough. You can Google me if you're interested, or Bing. You could use Bing. A fellow Microsoftie used the joke at a conference I'm going to steal from him. Bing, it's a search engine. Google it. You'll know what it is. All right, get ready. Each slide, you're going to see something, and you're going to try and count it, and then you're going to see the answer. So no calling out. It ruins it for everybody. Anybody not get that one? All right. I'll give you another try just to make sure. All right. How was it? Did anyone get it? Oh my God. 2. Wow. I could not even count how many people got it. That's how bad I am at this. How many got that? All right. People are happier now. Gave you an easy one. Left it on the screen for a little while. How about that? How many? Yeah, all right, good. Proving my point. I bet nobody got that? Am I right? If you did, you're lying. Okay. Okay. So this kind of reminds me of project estimation. The big things, it's kind of hard to figure out how many you saw, in the same way that it's hard to guess how long something is going to take if it's big. Anyway, we'll get back to this. I've been doing this microservice thing since before it was called Microservices, like probably many of you have. And for me, it all came out of a quest that I was on as a technologist. I come from the world of technology, of music, sorry. And I got to pull my phone out because, like Chris, it says 50 minutes. Oh, wait, suddenly it says 48:56. I come from the world of music, and I grew up as a musician, a professional musician, thinking that the word legacy was a good word. And then I joined the software industry, and suddenly it's a pejorative. It's an insult that you use for somebody. So I went on this years-long mission to try and figure out how can we bring that word back, and how can we actually create a legacy in the software that we build. Because if you think about it, most of the work that you do today will not outlive you if you're lucky. Your software will probably die within the next few years, and pretty much everything you're just spending your time toiling over is going to be thrown away, and no one will remember any of your work once you've died. So that's kind of a sad state of affairs for the technology world. We kind of suck. But musicians, it's different. You might leave a legacy. This is Beethoven. Beethoven left such an important legacy that even Americans can pronounce his name properly. Kurt Vonnegut, authors, kind of the list goes on. Art, the entire world, other than software, pretty much thinks of the word legacy as a positive word. So I started thinking about, well, why am I throwing away software all the time? And I spent many years of my career basically going into companies that were in trouble and throwing away the work of some other programmer and creating a new rewrite of it. That's basically what I've been doing over and over and over. And at the same time, I'm now 44 years old, and I don't take very good care of myself. And you all are really working hard to take care of your systems, and yet they still cannot survive. So what's the disconnect? There's something that's happening in biology that is much better than what we're doing in software. So I got hooked on this concept of cellular regeneration. If you think about it, even if it comes to stuff like cars, people are driving around almost 100-year-old cars, and they're still working today. That's because they're made of small components that can be replaced. In biology, we are made up of tiny little components that can and should be replaced. That's part of how we continue to survive over the decades. You've all heard that you are not the same physical being that you were when you were born. And that's actually not 100% true, but it's relatively close. And that's because we're made of these tiny components with clear contracts that are forcibly replaced. The cells, they're killed. And your body is the system. So I've been doing a lot of thinking about this. I've built systems based on this as a fundamental metaphor, and a lot of conference speaking and writing about it. And for a while, I was going around doing this talk called Legacy, and I would get to a slide. It didn't say awkward pause on it, but it otherwise looked like this. And I would say, maybe, it was sort of a non sequitur, maybe there's a universal truth that the key to all of this being good is that there are these tiny pieces. Maybe small is good. And I would sit there and think about it, and it didn't really work in the context of the flow of my story, but it kind of stuck in my head. So I was invited to do a talk at a conference called Code Mesh a few years ago in London. Code Mesh is one of the most hardcore, nerdiest tech conferences that you'll ever go to. It's sort of like Strange Loop, if you know that one in the US. But I think because it's smaller and it's in Europe, it attracts maybe a higher quality of attendee and speaker. Just because once you get into kind of a popularity situation, you end up with, noobs that wander in and don't really know what's going on. But Code Mesh is just like, creators of languages and people who created Erlang and stuff like that. So I was invited to speak, and I was absolutely terrified. I was living in Berlin at the time, so it wasn't very far away, thankfully, but I was invited to speak, and I was excited because it's like the conference made for me, because I am a nerd. Some of you were talking to me at lunch, and I just started pontificating about language features and stuff. That's just who I am. And I said yes, and it was a keynote, so you don't have to submit a proposal and tell them what you want to talk about. The way keynotes work is someone emails you and says, will you keynote at my conference? And you say, okay. And then you have to figure out what you're going to talk about. So it's kind of a weird, stressful situation because you don't really know why they wanted you to do it. So I'm ruminating for a while, and finally, I always do this when I speak. You can see this is 2014, almost exactly 4 years ago. I couldn't figure out what I wanted to speak about. And part of it is because I knew it was all these brilliant, hardcore, nerdy computer science type people there, and I'm just this musician that stumbled into software, so I was afraid. But I couldn't figure out what to talk about, and I got all kinds of ideas. And the way I usually build talks, including this one actually, is I come up with one concept and one word, and I let that be the center focus of the talk. So before I'd been doing this legacy thing, as I mentioned. So I was looking for the right word, and I realized I'm having a lot of trouble thinking of anything or being creative. Maybe this is my word, burnout. That's why. I was totally burnt out, so I thought, well, maybe I should talk about burnout. And then I thought, wait a second, why am I burnt out? Why do I feel this way? Well, it's because I've been working on this thing. It's called Wunderlist. And I was the CTO for Wunderlist. That's why I work at Microsoft now. We were acquired 3 years ago. I was the CTO, and when I joined, they had this monolith, a Rails monolith that they had built. And they were very, very successful. They had just done a major rewrite and released Wunderlist version 2, which was their all-native clients. Went on to win Apple's Mac App of the Year and was constantly featured in the global app stores. Really, really successful. People loved it. But when they released it, it immediately crashed. Literally within the second they released that update, their backend crashed, and it was down for weeks, actually weeks. This happened right after I signed the offer letter to join the team, but before I joined the team. So it was a really awkward time. So I joined in the middle of a disaster, and at the same time moved from the United States to Germany, and so I was basically jet lagged for a year. It doesn't really take a year, it takes half a year. But we had to do, guess what, yet another rewrite project, which I had said I was never going to do again. So we ended up doing this massive project to completely rewrite the back end, the sync protocol, because the sync protocol they had created for synchronizing your tasks, it's a task management application, by the way. There's no way it ever would have worked. And because the sync protocol was broken, and the back end was broken, and the database design was broken, we had to redo everything. So it ended up being this massive project, huge release, on a huge, weirdly huge, monolithic back-end code base that had all this strange stuff in it to counteract the fact that it was so huge and unmanageable. And the team had made huge commitments to the venture capitalists and to the users who were now desperately sort of angry because Wunderlist wasn't doing what they wanted. The VCs that were on the board were basically coming in, and they didn't tell me this when I joined either, but starting the process of micromanaging the team to perhaps eventually replace the executives, you know how that can happen. So there was a whole bunch of risk associated with this thing. They basically had one more chance to get it right. And that's probably the only reason they could justify paying me as much as they did to join a little startup. So, did I mention it was huge? Everything about this was huge. And that's when it dawned on me. Back to my slide with the little bug from before, the opposite of all of those statements that I made would be tiny. So maybe that's what I should be talking about. So, all of this sort of started for me, this thought process, when I went to a thing called Extreme Programming Immersion in 2001. I was one of the early proponents of the thing called Agile before it was called Agile. In fact, they literally wrote the Agile manifesto and published it while I was at the XP Immersion, and one of the authors of it sent it to me. But it was, in this environment, they had, this is Kent Beck here on the left. He's the person who coined the term extreme programming and started that movement. Also design patterns and software, test-driven development, stuff like that. So really amazing, influential person in the software community. I got a chance to pair program with Kent Beck at this XP Immersion. And it was one of those things where he was just walking around the room and I was pairing with my partner that was in the class, and he heard us talking and asked if he could sit down and pair with me. And what I had said was, I don't know if we should write a test for this. I think that's what I was talking about when he heard, and that was interesting to him. He'd been basically really focused on pushing TDD, test-driven development, as a concept at that time. So he sat down with me, and from this process of learning TDD and sitting with Kent, I developed this understanding that I think is really fundamental to how software works, and maybe even just how problem-solving works, which was, TDD, which I think of as a refinement of error-driven development, where you do something that doesn't work and then you fix it, and you just keep making things that are broken and fixing them over and over. It's motivating, because you have something, right? The concept there is you have a failing test, and then you implement until the thing is green, it runs, and then you go refactor it and make it better, and then you start over again. So red, green, refactor. What you learn when you do test-driven development, any of you do test-driven development? Very few. You're at an infrastructure conference when people aren't really obsessed with that. What you learn in that process is you're taking really small steps, and at every layer, you get to look at the problem and say, okay, I've got to do something, and there's a hard part in there somewhere, but what I'm going to do is defer the hard part till later and just make the easy part work. And then you run it, and you get through this cycle, and then you say, okay, now I've got something. There's a hard part in there somewhere, but I'm going to defer the hard part, and I'm going to do the easy part and make it work. Now you've got another passing test, and you keep going until you go from 0 to thousands of passing tests, and you keep pushing that complexity away. You keep pushing it down out of view. And eventually what you find out is that the problem space gets so small, there's no hard part left. You never got to it, because you keep pushing it away and just doing the easy part. Because you're breaking something large into something tiny. And at the bottom, it's small. It doesn't need to be hard anymore. And the same thing was true in agile software development done right, extreme programming, where you push the complexity of a project away. Because you look at an entire project and the business requirements you have, and you break it into actually small iterations. And those of you doing Scrum today with a Scrum Master and like 3-month iterations, I'm sorry, that's just waterfall, but you just call it something else. That doesn't count. I'm talking about small iterations the way that it was actually meant to be from the beginning. So just think about it that way. You're pushing the complexity away, just like in code. You end up with small pieces. And everything in XP ended up being about pushing things away and taking a big problem and breaking it into small problems and doing one small thing at a time until it's all gone, that I realized there's just something fundamental about extreme programming and agile software development that is here and can apply to everything, whether it be programming or even just how I deal with my life. So it reminds me of this quote: "Alas, agile has failed, but its essence remains." And I take this to mean its essence is this idea of breaking things into tiny pieces and pushing away the complexity. This quote is by me, but it sounds better if it's a quote. So here is my thesis about agile software development and tininess. Much, or maybe even everything, about software development that's hard. Leadership, product management, project management, it can be boiled down to one small idea, which is just to keep things small where you can. So I could just end the talk now, but I think I'll keep going for a little while. A little bit of dissonance for you. See if these phrases sound weird. Massive elite team. Huge efficient code base. Long successful project. Enormous agile company. None of those sound right, do they? Like, they actually kind of don't even come out of the mouth properly. And why is that? Well, I wonder if it's actually, I hope, and I will try to convince you that it's because we as humans have limits. Because if it's not humanity that has the problem, then it's me. And I'd rather it all be all of us than just me. So, starting with some research here. Not research that I did, I just binged it, of course. But you've probably heard this one or some variation of it. They're the most highly cited, or one of the most highly cited papers in the history of psychology is this one by George Miller, where he proves that humans have a limit for the capacity of information that they can process. And the magical limit is 7 plus or minus 2. So 5 to 9 items are what you can actually process. And I think if I just say this to you, it probably holds true. You think, yeah, that makes sense. It rings true, I should say. If you're a manager, you probably think, well, if I have more than like 9 direct reports, then I probably have created a problem for myself. I know that's the case for me, and I'd really rather it be more like 5. And the reason behind this is you have two different types of memory. Similar to how a computer works, you have long-term memory, which is essentially, or maybe effectively infinite, but it's slower to access. And then you have, what have I done here? Oh, there we go. B blacks the screen, just so you know. And then you have short-term memory, which is more like the stack or memory in a register in a processor. This is the memory you actually need to work on stuff and to think about things. And this is much faster to access, but much, much more limited. So this is where the 7 plus or minus 5 things comes from. That you really only have the ability to manage up to, say, 9 things in your short-term memory, which means you can think about and actively process up to 9 things, but that's even stressful. So then we have this concept in psychology called chunking. Does anyone get the reference? Old people, yes. It's kind of hard to search for on the internet, too, if you don't, unless you have one of those Google image search things, Bing image search things. I'm going to stop telling the Bing joke in a minute, I promise. So chunking is the ability for individuals to group things. So you might look at a larger group of stuff, group it naturally, and then be able to think of it as a smaller list. So there was one of the Subitizing examples that I showed you. I think it was 9 items, but there were 4 of one emoji and 5 of another one. And pretty much everyone could see it was 9, because you could easily count 4 and 5. So you've basically taken 9 and you've turned it into 2. That's what your brain did. And this is proven to be correct. This is proven to actually be the case. There was another guy named Nelson Cohen who came along and proved that adults actually do this. So it's not really 7 plus or minus 2. It's more like 3 or 4 things that you can actually actively manage and process. But we have cheats and workarounds to do it. On top of all of this, if you have a good short-term memory, good working capacity, if you're built with the processor and the hardware internally that makes you smarter than everyone else in this way, you are still likely to crack under pressure, which means you have to really be relaxed to push the limits of these things, even if you're really, really smart. So humans are just not good at dealing with big things. They're good at dealing with small things. I feel a little bit vindicated now. So, things that are better served small in our world. I'm not going to read these lists, but you can look at it. You can see, commits, classes, stuff in code. There's never a case where you go do a code review and you say, that method should have been larger. Never. You've never done that before, right? And if you do, well, no. Let's not even argue about it. I would even say servers. I remember there was a time when we used to buy these massive servers. I used to be so proud of the 2 years of uptime on our Enterprise 10,000 when I was at GE in the early days, or whatever it was. Basically, everything is better served small, especially failure. So I'm going to talk about 3 major areas that can be improved by focusing on keeping things tiny. The first one I can go quickly on, because most of us will understand this. So it's really weird because for the first time in a long time, I have someone from GE, from the specific division here. Really nice to see you. But when I was back there in like 2000, 2001, I had this book by Martin Fowler. We're not related, so I can talk about it, and you don't have to feel like I'm trying to sell it to you. And it's a hardback. It used to only be hardback, which means it's very heavy, which makes it a good weapon. I would walk around, and we had all these outsourced teams that we brought in, and they had come from various places in the world. None of them actually lived or had originally lived in the place where we were in Louisville, Kentucky, because no one's from there. And they were doing a bunch of Java development. You're from Louisville, Kentucky. Hey, nice. Yeah. You're not, though, are you? You're not from Louisville? No, okay, good. See? Did you work at GE? Humana? Oh, cool. What? Oh, you interviewed there. Well, congratulations on not being hired. Yeah, we don't need to throw the box at you for that. I'll repeat the snarks. So we had all these outsourced teams, and I had gone on this crusade. I would carry around this book, and the teams, we were spread across all these different buildings. It was a big manufacturing facility. And I would show up with this book, and it really was like the team who would say, oh shit, here comes Chad, because I'm going to talk about their code, and I'm sorry I used the bad words, but that's what they said. And we have a president now, but anyway. I'm going to talk about their code. They're not going to feel good afterward. They're going to have homework to do. But I would carry this thing around, and I held all these sessions, and we had design reviews that we would do together, so everyone was looking at the screen and critiquing each other's code together, trying to develop a shared understanding of what good is. I spent a lot of time talking about software quality then. And then one day, there was an outage, and I'm troubleshooting this outage, and I'm like, decompiling Java code on the server and all kinds of stuff that would not be allowed anymore because of Sarbanes-Oxley. And I found the cause was in a 10,000-line enterprise Java bean. One class, in fact, most of which was in one method, which was 10,000 lines long. And I thought, what can I tell you from here to eternity if you're the kind of person that's going to make a 10,000-line Java bean? There's nothing else we can talk about except keep the damn thing small. So that's where I learned. I instituted a rule that no unit of code could be more than 5 items long. And this is without reading those scientific papers. But every method, if it was more than 5 lines long, then you were not allowed to have it. Wrong. It's wrong. No reason to have a code review about that. No class can have more than 5 methods. That was just the rule. 5. Done. And at that point, we no longer had any more 10,000-line Java beans. And I would say that the code generally improved just because of that stupid rule. But you think about it, think about the worst code you've ever seen. If everyone just followed that rule, probably would have been pretty good, or at least much better, right? I would love to know if you disagree with me. Small methods also pass this interesting test. So when I was sitting with Kent Beck, pair programming, and the answer to the question, should I test this? He said, well, the rule is test everything that could possibly break, which is frustrating because you're like, theoretically everything could break. But his point was, look at it and just try to determine, do you think this could break? And if you don't bother writing a test. It's stupid and it's a waste of time. You're being sophomoric. There are almost no reasonable 5-line functions that could break. And if you look at like Haskell code, I doubt many of you are Haskell programmers, but you all should be if you're programmers. If you look at Haskell code, all right, you'll find that not only do they not test it, but the functions usually even have like parameter names like M and X and F. And no one's confused because the functions are so short, there's no way not to understand it, unless of course you don't read Haskell, but that's your problem. Parameter lists. If you have a method or a function or anything that has a bunch of parameters, more than 5, probably much less than 5 is the limit you should have, then you know it's not good. You just know if you're a programmer. You shouldn't have 10,000 line classes and modules. I'm just skipping through stuff. And the same goes for your services and your actors and applications. Basically everything you know is better in code if it's small. Even systems. And that's a weird one because you could think of your whole company as a system, maybe, but you probably ought to not, right? So I think of all these things back here, classes, modules, services, these are the cells in a system. They need to be small enough that you can replace them. And Chris actually mentioned earlier, he doesn't think you should focus too much on tiny. He thinks you should focus on, and I'm not like trying to debate with him because I agreed with just about everything he said, you should focus on the size of the team that it requires to maintain a system, or a microservice, in order for it to be a microservice. I think the way to think about microservices is they are cells. Cells should be regenerated, which means they should be destroyed and replaced with absolutely new ones. And every cell in the system should be small enough that you're okay with doing that, and it's not a massive overhead. And I could talk for a lot about having done this in the past, but it really, really works. So think about that. All of your code should be disposable in small pieces, just like your bodies in the system should survive. Same is true with data. At Wunderlist, one of the big problems we had was scalability, as I mentioned. The reason for that, a lot of it, was massive databases. Like every task and every piece of data that our millions of active users were adding was in one database, so we had a massive database. So then you go out and you ask geniuses in the world, how do I deal with this massive database? How do I make sure that I can scale a massive database? And it becomes a problem of data scalability. Well, one way to do that is just don't ever have a massive database. So we switched from one massive database to every user has their own tiny database. Problem solved. No more scalability issue ever for the rest of our lives. Done. In fact, we haven't touched this infrastructure since we were acquired, and it's still running, still growing, and have never had a scalability problem since. Commits to code. You're making changes to your code. Do you like massive commits? I hope not, because I don't want to be on your team. Because if you do, it's harder to change, it's harder to roll back, it's harder to review. Small commits that do one small thing, easier to reason about, easier to understand, and easier to maintain. And I talked about Kent saying test everything that could possibly break, so I don't need to mention that again. So you might be thinking, that's great, but my code is inherently big. No, it isn't. You know how to do this. Okay, moving on. Teams. So the second of the three things I want to talk about. I was SVP of technology for a company that no longer exists called Living Social a few years ago. It was one of the unicorns, competed with Groupon, ended up losing to Groupon and getting acquired for basically nothing, if you read the news. And we went from a 10-person team right before I started to 300-something people reporting to me within 2 years. So this is a funny case where I grew a massive elite team. It actually existed. although it's not actually true. It was a massive team of elite programmers, because I got a who's who of programmers that, it was even an open joke on the internet. We were just hiring everyone. It was a brain drain into living social. But what I learned in this process was, even though I was getting the best programmers I'd ever known to work for us, we put them together in this large team, and we couldn't really get much done. It was extremely frustrating and a really interesting learning experience. The one takeaway that I had is, wait a second, this team is like a system. So all the stuff I just said about code, if you think about it, code and its modularization and its maintenance is all about communication. It's about being able to understand intent and separate things into the places where they should be. Teams are exactly the same. So I created a modularized system of the teams, and we ended up, of course, operating better in that way. But the key was, one massive team, obviously not going to work. And people always ask me that now, because I keep getting involved in situations where I'm a manager, where I hire people rapidly. I don't know why. It's one of the other anti-patterns of my career, along with the rewrites. I'm rapidly hiring teams of great people. They ask me, well, how is this going to work with one team of all these great people? And the answer is, it's absolutely not going to work. Definitely not going to work. We need many teams, many small teams. Speaking of our president, this book, I don't know if I want to really encourage you to read this book, but there are some interesting pieces, so I'll tell you a couple of them. One quote that stood out to me when I read it: a new company's most important strength is new thinking. And I think it's probably not just true for new companies. Any company's most important strength is new thinking. Even more important than nimbleness, small size affords space to think. So space to think, that sounds important. Small size affords that. And if you think about it, it's true, right? When you're on a small team, that's part of what you get out of it. When you're on a massive team, you kind of feel compressed by the noise. There is, of course, research behind this too. This is Robin Dunbar. He's an anthropologist from England. He coined a term based on his research, which is Dunbar's number. And most of you would have heard of this, but you probably haven't read this paper, which is coevolution of neocortical size, group size, and languages in humans. Now, what this means is there is some sort of correlation between the size of your neocortex and your ability to form bonds with people and your ability to communicate. And here's what the neocortex is. The neocortex is responsible for stuff like spatial reasoning and motor commands, but more importantly, conscious thought and relationships, things that we really care about in this context, right? And he did this by studying apes that do social grooming. So that's where you sit with your friends and pick insects off of them, off of their heads, and then probably eat them. He extrapolated from what he learned from the apes into humans and said that language is the human equivalent to that bonding mechanism that they had. So if you look at populations of apes, the social grooming shows you what the actual cliques of the apes are. Not as fun, but certainly more efficient and maybe not quite as dirty. But this is how we communicate. And what he did is he extrapolated based on the size of our neocortexes and figured out that humans, across all of our relationships, can maintain at most 148.45 or something relationships that actually mean something. That's it. And that's work, family, friends, old friends, new friends. So that's all you've got, pretty much, based on what you have as your hardware there. And this was popularized by Malcolm Gladwell in The Tipping Point, which came out in year 2000 or something like that, where he talked about Gore Associates, who make Gore-Tex. And the story there was that Gore figured out that their factories, their facilities, could only have 50 people or 150 people in them before communication broke down and things got less efficient. And of course, their company is larger than 150 people, so they even went so far as to say, when we build a new building, there will only be space for 150 people. There will be 150 parking spots. Only 150 people can work in there. If we need more space than that, we make a new one that can also fit 150 people. That's it. And they found that that is the way that They have the best interactions between teams, so they have units that are 150 people max. In the militaries around the world, they've also figured out the importance of small teams. And in militaries, there's a concept, and I say militaries because it's not just ours or someone else's, concept of a fire team. So you learn this if you join the Marines, for example. It's 3 + 1 people. There are these small, elite, autonomous teams. And studies have shown that organizations in the military that use these small autonomous teams like this are statistically much more effective than teams that don't use this fire team structure. So it may be a very large group, because you're fighting a war, not just having a little skirmish between a few people, but you work with these fire teams to do it. Back to the software industry, QSM, which is Larry Putnam's company. Larry Putnam is an early software estimate kind of researcher and expert, and responsible for, as I say here, the Putnam model for software effort estimation. They did a study, and they figured out that given the same amount of work, but different team sizes, that the smaller teams on the exact same amount of work always delivered faster and cheaper. Same exact amount of work, more people gets you less results. Same thing echoed here. This is actually one of the founders of Scrum that posted this from another study. Teams less than 7, same amount of work, for one function point in whatever definition they were using. Team sizes less than 7 would cost $566 per function point, and teams greater, and the average was $2,970. Same exact work, but the average cost is lower with smaller teams. Duh. Larger teams need leadership, of course, so there's all this overhead, there's stuff you have to do, there's whining in larger teams. I don't know if you've experienced that. I've got a large one now, they all whine. They talk a lot. We moved it from email to Slack now, apparently, but it still happens. Lots of communication overhead. So that's great, but my team is big, yeah? Well, there's an obvious solution to this. Make a bunch of small teams and give them autonomy and give them specific responsibilities. Again, back to software design. You don't make a 10,000-line enterprise Java bean. You all laughed when I said that. So make small teams and use the things that you know from how systems work so that they can work well. And when I was at Wunderlist, we actually did an experiment with this where our team had grown to about 70 people. It was too many. We had done these big monolithic, scary projects that I told you about that burnt me out. And we ended up moving to small teams that were autonomous and not driven by us. And our velocity picked up crazily as soon as we did this. It was like 3 months was a year's worth of effort before. Then after that 3 months, our management team got afraid and started micromanaging and taking away the autonomy and raising the team sizes, and we ground to a halt. So don't do that. All right, so projects. Another quick personal story. In 2005 and 6, I got out of corporate America finally, and I joined a small company. It was not quite a startup. I guess you'd probably call it a startup. I was the lead developer. I experienced the worst burnout of my career. So bad that maybe I haven't recovered from it yet. It was another one of those situations where I went in, I interviewed, I said, hey, all right, they wanted to do a replacement of their PHP system in Rails. And Rails was very early in this time period. And I was a thought-leading Ruby Rails expert somehow. So I said, okay, we can do this, but we have to do it in small pieces. And we have to introduce them and run things in parallel and repeat component at a time. And we need to start with new functionality so we're not screwing up customers that are currently using it. We made all these agreements, and then when I joined, they had changed their minds and we were doing a big rewrite. So we did the big rewrite, after which I wrote this article series called The Big Rewrite that a lot of people read at the time. It was on like #1 on Dig, if you remember what that was. Detailing why you should never do this. So you could probably read between the lines and see it was just me getting my frustration out. as I said, we redid it in phase. It took a year to finish. Here's a picture of the development team that we took going to lunch during the project. The customers hated it when we finally launched it because it couldn't perform. The actual functionality they got, they didn't like it. They didn't like the redesigns. There were all sorts of reasons because we delivered this big blob of crap at the end, and it just didn't work for them. And what's sad is I knew that I should have stopped it. I was old enough to know better at that point, but I didn't stop it because I was scared, I guess. I don't know. We have this default setting that we just do things like this. And ultimately, we had to throw it away. We blew it up, actually an entire year completely wasted. Not just of the company's money, but of my life. That's pretty sad. I mean, my wife thought I was going to die, actually. Like, literally thought I was going to die because I was so stressed. I worked so much, and I just took so much responsibility in this thing. And as I said, it took me years to recover. And I still am kind of skittish about signing up for stuff now, but for a while, like, I lost my creativity for a long time, and I didn't care about learning software stuff. It was bad. So why do these big projects suck? Well, you know, they're hard to estimate. There's too much change, both for your organization and your customers at one time. That's another thing I don't know if I mentioned in my list. Things best served small, change. You can only digest so much at a time. There are huge risks associated. In the case of this project I was talking about, we wasted an entire company's year, lost our credibility with our customers, and burnt out several human beings in the process. There's no reward until maybe the end, unlike ours where there was no reward ever. But even if you do it perfectly, there's no reward until the end. And if you're a company that cares about making money or getting agility or something, being able to do that more frequently is obviously better. Just like time value of money. If you have money sooner than later, that's better for you. And you don't learn anything until the end if you do these massive projects. That's why you want to do small projects. And then, as I mentioned in our project, practical things like, will people even understand this and will it perform, they get overlooked because you don't have time for them because you've got this massive thing going on. And you need to aggressively manage your dependencies in these big projects. And we just can't do that because there are too many of them. And as I said, we're not good at managing big things. We're only good at small things. So CFO Magazine published this study, and some interesting numbers here. 40 to 60% of Fortune 500 projects fail to meet their schedules, capital projects. And nearly 6% of revenue is spent on them. Huge, terrible waste. So a little bit more to support this. Now, this is a boring slide because everyone obviously knows this. This is the Standish Chaos Report. They do surveys of large companies across the world, and they publish the results every year. What they find is in 2012, and it's always the same, so it's always so much the same that they probably ought to not bother doing it anymore. It's probably boring for them to do it, but 39% of projects were successful, 18% failed, and then the rest were challenged. But their definition of challenged is significantly over time or over budget, which to me is failed. So basically, 60% of projects fail, is the way I look at it. That's probably not surprising for you to hear, especially when you're talking about big companies. Here's the thing that might be more exciting and more surprising. And really, once you look at this, if you believe this data, then we should be done. This is the end. Never do it again. Small projects, 76% are successful. Large projects, 10%. Okay, never again, right? Never let a large project happen again. You've seen this. If you do it, it's your fault. It's going to fail. And if it succeeds, you don't get credit if you let it happen. Who was this that did this? Polytechnique Montreal studied Firefox, the development of Firefox as they moved to shorter release cycles. And they also proved that they get significantly less bugs with the shorter release cycles. So, duh, kind of obvious. That's great, but my project's big. You know what to do. Make it many projects if you can. Sometimes that's hard, but usually when it's hard, it's for a reason that is not set in stone. And if you can't make it change, it's probably because someone's afraid. So break through that fear. Fear drives us to most of these problems. Do short releasable iterations if you can. A month is not a short iteration. 3 months is obviously not a short iteration. Do really short iterations. You're going to love yourself for it if you do. And as I said, delay the complex stuff till later. Push it away. When something seems really hard, find a way to do it later and to do the easy stuff first, and just keep doing that with every iteration. It's life-changing for your company, for your team, for yourself. All right, 6 minutes and 11 seconds left on the clock. Let's wrap this up. Okay, doesn't this just introduce incrementalist thinking if you think in tiny parts? Well, yes, if you're dumb enough to just think in tiny parts all the time. It doesn't mean that you have to just always think about small stuff. Small is a tool, and there's another quote from the Peter Thiel book. Making small changes to things that already exist might lead you to a local maximum, but it won't help you find the global maximum. Well, that's bad, right? And he talks about this when he's discussing the lean startup movement. Because we want the global maximum. We don't want to be just stuck in this incremental thinking. But here's the key. Leanness is a methodology, not a goal. And I would say the same thing. Don't throw away what you know. Tininess is a methodology, not the goal. Microservices are a technology and a tool and a methodology, and not at all the goal. Although a lot of us think it's the goal right now because we're confused. So, should we just get better at doing large things? Is this a crutch? I mean, you probably hear people talk about this with microservices too. And isn't all this the same as decomposition, cohesion, all the stuff we already know from software? Yes, in a way, although I would say those things are actually the same as this, because this is the fundamental truth. Small things are easier for humans to deal with, humans to understand. And why does all this matter? Well, here is something that Sequoia Capital posted almost, I think, 2 years ago now. This is the microservices ecosystem back then. It doesn't matter what's on this. I think we really risk in this revolution that we're going through now, the microservices revolution, we risk getting caught up in this stuff. Tools, technologies. And when you do that, well, yeah, microservice is good, but it's also just a poor re-implementation of Erlang. So there's nothing special here, right? These are the tools. And tools are incremental gains, typically. But we saw this already. And if you've seen this, then screwing around with what programming language to use, you know that doesn't really matter that much in the grand scheme of things. It's this that matters. This is the kind of gain that you want, right? So fix this. What's scary is that keeping things big is worse than a dogma. Because I don't think anybody here is sitting around in meetings at work arguing to make something large. Well, let's do a massive project instead of the small one you want to do, boss. You don't do that, right? It's worse than a dogma because although you are not arguing for it, there's no one fighting for this bad behavior, it is the default setting for some reason. We as humans are geared toward understanding small things and creating large things. It's our fatal flaw, maybe. So I encourage you to mindfully strive to keep things tiny. It's hard because the default setting is to keep things big. And many of you are already advocates. You're here advocating because you probably came from a company where you're doing monoliths and you're trying to get people to start thinking this way. So you're used to being an advocate. So in between all of that sort of advocacy that you already do, be an advocate for the thing that matters. Thank you.